Good afternoon, everybody. Welcome to section 1.4's. There it is, right in the corner. 1.4. Section 1.4 is homework helper. I'm going to go over the last one we have this week before we have the test tomorrow. So let me go over some of the things you're going to see in tonight's homework. This very first section should be mostly review, where what it's asking us to do is evaluate for the indicated function values. So it'll give us something in function notation. We'll get an f of n in many of these cases, and then it'll ask us to use whatever value they plug in for n here to evaluate it. So for this one, where it's 5n plus 8, and we're looking for f of 4, all we do is substitute 4 in for n and add 8. 5 times 4 is 20, plus 8 is 28, and we're done. This is kind of review of what we've been doing already, so it shouldn't be that new. I will point out that this row here, we're using exponents. So for example, this is going to be 5 squared, or which is 5 times 5, or 25. So just keep an eye out on that. It should be pretty easy. The next section is a little bit more complicated. It has to do more with some of the concepts that we've been working on so far with recursive, explicit, and then geometric and arithmetic. So for the first thing it wants us to do is to find the next 3 terms in the sequence. So when I look at number 9 here, I see I go from 3 to 8 to 13 to 18 to 23. And so one of the things that I'm able to see is that each time I'm adding 5. I'm adding 5. And if I wasn't able to see that, if you're looking at that, one of the things you can do is take one term, one of these middle terms, like 18, and then subtract the term before it, so minus 13, and you see that that's 5. And then take 13 and subtract the term below it, and that way you see that that's 5. If these numbers are the same, then you know you have found your pattern, you found your common difference. And so now that we have that, we can figure out what next is. So 23 plus 5 will be 28, plus 5 will be 33, plus 5 will be 38. And I can see that my common difference is going to be plus 5, because that's how much I'm growing at each step, okay? And it says constant difference here and common difference here. It's pretty much the same thing. And then it asks us to write a recursive function and an explicit function. So for the recursive function, I see that I'm adding 5 to the previous term. So I know that f of n is equal, so any term is equal to the previous term plus 5, right? F of n is any term, and f of n minus 1 is the previous term minus or plus 5. So that's how we do that. Now the explicit function is a little bit different. For the explicit function, we have to see what we're doing. And so I always like to build that chart, right? So that we have our term number and our output number. So at term 1, I have 3. At term 2, I have 3 plus 5. At term 3, I have 3 plus 5 plus 5. Like that. And so the pattern that we're looking for here is how many plus 5s do we have? We see at term 2, I have 1. At term 3, I have 2. So I'm always adding 1 fewer plus 5. So I always have f of n is equal to 3 plus a number of 5s equal to 1 less. 1 less. That is one way to do it. Another way to do it is to look at our 0 term. So we have our first term, which is 3, but we can imagine going backwards, right? I'm going to sticky note this here like this. We can imagine going backwards so that we had a 0 term, like so. And if this were the case, if I'm adding 5, well, that means I'm subtracting 5 each time, right? If I'm subtracting 5 here, I would have negative 2. So another way I could think of it, and in this case, is that when I get to 3, I'm adding 1 5. To get to 2, I'm adding 2 5s now, right? Here, I'll redo it. So I have n, f of n. 0 is negative 2, 1 is negative 2 plus 5 to give me 3. 2 is negative 2 plus 5 plus 5 to give me 8. And so now I can see that the number of 5s I'm adding is equal to my term number. So my explicit function would be f of n equals negative 2 plus 5 n times. And so that looks a little bit more clean than our original 3 plus 5 times n to the negative 1. But I do want to show you that those are the same thing. Those are absolutely the same thing. So let's look at what happens when we evaluate our first expression. If I have f of n equals 3 plus 5 to the n minus 1, and I distribute this 5, I have 3 plus 5n minus 5. 3 minus 5 will be 5n minus 2 is my f of n. And sure enough, that's the same thing here if we just switch those around. So they both give us the same answer. It's kind of whatever works for you. So I like this one the best because it just looks cleaner. But what I'm going to do right now is I'm going to give you a generalization. I'm not sure if we're going to have time to do the generalization in class today so that you guys have it, but I at least want you guys to have it. So the generalization of arithmetic series. Okay, this is pretty important and definitely something you should have in your notes and possibly on a note card for the quiz tomorrow. So when we generalize arithmetic series, we're looking at two things. We're looking at recursive and explicit. So recursive for any arithmetic series is going to be f of n equals f of n minus 1 plus whatever this common difference is. So I'm just going to call that CD. Okay. So if you know it's an arithmetic series, meaning we add or subtract each time, and you can tell what the common difference is, all you have to do is write this, and you have written your recursive function. It's pretty simple. Now it gets a little bit more difficult when instead of recursive we're looking at explicit. But here's how explicit works. Your f of n is going to equal your common difference times n, okay, whatever your common difference is, times n, plus your starting amount, your zero amount. So I'm going to write n with a little 0. This means the 0th term. Okay? So when we look at this here, we try to identify what our 0th term is. Here it was negative 2. So I could tell that since I add 5, it would be 5n minus 2. And sure enough, that's what we end up with. Our 0th term here, whatever our term is at 0. So that's just our general way of doing it. It's pretty good stuff. I would hold on to this sort of information because it's really powerful. Yeah, let's turn the page. All right. The last handful of questions are making a connection to this graph. So Olaf is a mountain climber. The graph shows Olaf's location on the mountain beginning at noon. What is information in the graph to answer, or use the information in the graph to answer the following questions. So where is his elevation at noon? Here is noon. Here's his elevation. You just have to answer that. And then it'll ask you to find the difference between these. I feel like it's pretty self-explanatory from here how you should do each of these. The only thing you might need to know is like finding the difference here. But then you just have to kind of count what's the length between these dots. So if I go from 1,000 to 5,000, 2, 3, 4. So that's 2,000, 3,000, 4,000. So you know that each dot is 1,000. And that's all it takes to be able to figure those out. Okay, one final bit before I let you guys go for the day. Keep in mind, I give you the quiz topics each and every week on this page. This lets you know, in this case, 4 sections that I'm going to quiz you on. These are the 4 things I want you to be able to do. Equations and function notation, explicit and recursive equations, exponents, and graphing. All of these problems will be taken from the quiz itself. So go ahead and make sure you look at all of these different sections, because that is exactly where I'm going to be pulling questions from. All right, guys, that's it. Enjoy the rest of your day, and I will see you tomorrow.